So the next type of optimization problem we're going to talk about are what are called the rectangular pen problems. And by pen, I don't mean a writing implement. I mean, like, suppose you're on a farm or something where you've got, a pen where you're like holding animals and stuff. So, maybe like, this is where the chickens are, and this is like horses, and this is like, I don't know, like zombies, and maybe over here you could have plants. So, you've got a pen where you're sort of like containing stuff. And the idea is, if you've got a certain amount of fencing that can be used, what's the largest possible area that you can fence in, in a certain area. So that's going to be the kind of thing that we set up. So I've got a couple examples that we can look at here. So we'll move on to the first one. So this example, a rancher wants to build a rectangular pen with two dividing internal walls, as shown in the diagram below. If he only has 2,000 feet of fencing to build the entire pen, what is the maximum area that can be enclosed? So just like I said in the previous video, we want to draw a picture. We want to label this picture. I feel like one of the most common errors that people make in this problem is that in the labeling they'll say like, oh, well, this is X, and this is X, and this is X, and then this is Y. And I guess there's nothing wrong with that. My thought is, when you're working with a rectangle, universally, the dimensions, the things that we care about, are the length and the width of the rectangle. So this overall rectangle has a height of, let's say, Y, and this entire width of the rectangle would be X. There's really no point in breaking each one of these little pieces and calling each one of these things X. We should just call the whole length of the rectangle X. Right? So now that we have a diagram that we've labeled, we move on to what is our optimization equation. My optimization equation is, well, if we read through this thing, it says what's the maximum area? Great, A max. So what's the area of this pen? Area of this pen is X times Y. Right? Because there's multiple variables there, we're going to need a secondary equation. So what's my secondary equation? Well, we're told that he only has 2,000 feet of fencing to work with. So the question is, what is 2,000 supposed to be equal to? And the thing that you're going to come up with here is going to be an expression in terms of X and Y. So what you sort of need to think about is, what is the 2,000 equal to? Like, sort of, what's the total fencing that you have in this problem? And I really would recommend that you pause the video and think about this for a minute. And the answer is that it's going to be 2x, and that's because you have an x length here and an x length here. So whatever you decide to make x, you're going to need twice that much to do this. And then you'll have plus. Now for the y, you've got one fence that way, another fence, a third, and a fourth. You basically need 4 fences that are y units long, so we're going to have plus 4y on the end of this thing. Right? And at this point, we really just need to finish the optimization problem the same way we would any other problem. Like, at this point, we're no longer in word problem territory. This is now just a setup. We solved this the same way we would have solved any of the other previous problems that we looked at in the previous video. I'm now going to solve the right equation for, I don't know, I guess x. 2,000 minus 4y equals 2x. If I divide through by 2, I get 1,000 minus 2y equals x. Plug that into this equation. The maximum area is 1,000 minus 2y times y. So A max is 1,000y minus 2y squared. At this point, I've got a nice, easily differentiable function to work with, so I'll take the derivative and set it equal to 0. 1,000 minus 4y. And if I solve this thing for y, I'm going to end up with y being 250. So my y dimension is apparently 250. I'll plug this back in over here to find out what x is. I get 1,000 minus 2 times 250 equals x. Looks like x is going to be 500. And remember, we're supposed to answer the question. If you read the original question, the thing that we wrote down, the thing that we're supposed to find here is supposed to find what is the maximum area. Well, A max would be 500 times 250, which is going to be 125 with 3 zeros after it. So great. 125,000 square feet is the maximum possible area that you can contain using a 2,000 feet of fencing with the arrangement that this rancher wanted to have. I've got one more example after this one, so we'll take a look at that one now. So in this one, it's the same pen as before, same setup, but this time I don't want to look at lengths as much as I want to look at money. Right? This time the rancher has $12,000 to spend on fencing, and we're told that the fencing around the perimeter of the pen, maybe the external fencing, costs $5 per foot, and the interior fences only cost $1 per foot. So in other words, these fences out here are all sort of more expensive fencing, that's $5 per foot, and the fencing through the middle here is $1 per foot. Still ridiculously cheap fencing. I mean, like, if you ever get a deal to buy fencing, like, you should do it. It's a great deal. But I'm getting outside the problem. I still need to set this thing up, right? So just like we did before, I need to label this thing, and I'm going to do it the same way I did before. This dimension is y, this dimension is x. Right? That's my first step. I've got a diagram, I label the diagram, and note, x and y are lengths. This is like x feet, this is y feet. And I know this problem is ultimately going to be about money, but that just means I'm going to have to bring that in later. Right? My next step is for me to come up with what my optimization equation is. So in this problem, what am I supposed to be optimizing? I'm supposed to be optimizing what is the maximum area. So just like we did before, A max is x times y. So then I need my secondary equation, and a lot of people struggle with this one, so you may have to pause the video, you may have to look at this a couple times. What I have over here is $12,000 equals something. The question is, how much is it going to cost to construct this thing, right? And my thought for you is this: if this fence here is y feet long, like this is a length, how much is that fence going to cost to build? Keeping in mind that the outer perimeter is $5 per foot. This one should cost us $5y, right? It's the same over here. This one should also be $5y, right? Because if this length here is y, whatever y is, I'm going to multiply that by 5 to find out how much this fence is going to cost. What I need you to do now is to think, how much is this fence going to cost, how much is this going to cost, and how much are these two fences going to cost. So sort of pause the video, annotate your diagram, come up with those things. Hopefully you came up with the idea that this is going to cost you $5x, this is going to cost you $5x, this is going to cost you, 1y, and this will also cost you 1y. And so in total, this entire thing, we need to add up all of these and these. And when I add those together, we find that it's going to be 10x, that's 5x from here and 5x from here, plus 12y. That's 5, 10, 11, 12. Once you've got this problem set up, like it's the same thing as you've seen in the previous problems, but in this problem, what you really got to get and understand is, because this is about money, you need to take your x and y variables and turn them into expressions of money. So like I said, from this point, this should solve fairly simply. I would recommend, if you've got the time, pause the video, make sure you can get it on your own. I'm going to go ahead and walk through this now. I'm going to solve for, what the heck, I've been doing x tonight, so I'll keep doing that. 12,000 minus 12y equals 10x. I'll divide through by 10. When I divide by 10, that gives me 1,200 minus 6/5 y equals x. We take this thing and plug it in over here. A max is 1,200 minus 6/5 y times y. If we distribute that y through, you'll get 1,200y minus 6/5 y squared. When we take the derivative and set it equal to 0, because I'm doing that on every one of these problems, we get 1,200 minus, I'm sorry, that's not 3, that's going to be 12/5 y. So let's see, if I move this stuff around, 12/5 y equals 1200, and long story short, when I multiply a fraction over, we should get y is 500. And then I can take that thing and plug it back into this equation. 1200 minus 6/5 times 500 equals x. I'll save us the time. I think x here is going to be 600. So these are my two values of these things. And remember, we need to answer the question. The question was, what is the maximum area that can be contained? Well, we knew it was going to be the x dimension times the y dimension, which gives me 30 with 4 zeros after it. So 300,000 square feet is the maximum that can be contained if you've got, $12,000 at these amazing prices, and that's that. I was only going to do 2 examples. I just thought of one more thing, and I'm just going to set up. I just kind of want to talk to you about something in the next slide. It'll be disorganized, but we'll take a look at it really quickly. One way that I like to sort of make these problems more interesting sometimes is we'll say, what if you've got a rancher that wants to sort of build a pen like this, and he doesn't want to have a fence on the side because there's like a river there, and suppose you've got some animal here that's afraid of water, like maybe gremlins. There we go. Because you need fences on these sides to keep the gremlins in, but if gremlins go in water, it's just a mess. So don't worry about that. The question is, in this case, how much fencing would you need? And the idea is, if you called this dimension y and this dimension x, sort of the amount of fencing that would be required would be what? It should be x plus 2y. The idea is, I don't have to pay to build this quote-unquote fence because it's a river. Like, presumably the river was already there. So if you see any problems like that in the homework, that's kind of what I intend by that. That's the end of this one. That's all I have to say about pen problems. There are other ways they can be asked, but I assume you guys are going to figure those out when you get there. So good luck.